This is also a use membrane, different membrane types to support and to cover the area. And ARC supported are also with a series of frames used to cover the area, and the membrane were on the top to cover it. There are different shapes, parabolic, circular frames. In this diagram, we can see the forces of the snow or wind or rain. And the combinations, there are not only one type. They can use this type to combine different type of membranes. And the advantage of this structure systems is a longer life cycle of materials. Materials can be reused in form. Most materials are completely recyclable, less impact on site, unique designs, lightweight and flexible, less construction debris after demolition, environmentally sensitive, high strength-weight ratio. And the disadvantages of tensile structures are little to no rigidity, loss of tension is dangerous for stability, thermal values limit use, load transfer on fabric structures, attachment weaknesses in mono-cover fabric structures. So we can say the advantage is they are long life and they are environmentally, and it is easy to install it to cover a large areas because they are lightweight and they are fast to install. But the disadvantages is inattentional errors. They can be very dangerous, and so they should be calculated very well. And also the membranes, the life of membranes is important. And some famous projects and important architects. Fry Paul Otto, he's a German architect and a structural engineer. He generally worked with tensile and membrane structures, and the most famous work can be seen as Olympic Stadium in Munich for the Olympic Games in 1972. And this is the Olympic Stadium. The structural engineer was Fry Otto. The technical architect was Leonard and Andra. It's built in 68 and 72 in Munich, Germany for the Olympic Games in 72. The Munich Stadium complex for the 1972 Summer Olympics is a perfect example of how site and structure can blend together. Undulating roofs and dramatically sculptured earthscapes unifying the setting. Both inside the halls and out among the park setting, visitors are provided with a sophisticated series of experiences. This is a sketch before the complex was made. The climate is also important because in Munich there are lots of winds and snow of this region. So they have to calculate the roofs durable against the wind and snow forces. And in 72 they didn't use any computation computer softwares like CAD software or any other design software. So they all made it with, how can I say, hand. The roof Without doubt, the most remarkable feature of the stadium and the adjacent buildings is the tensile roof structure. It has become not only a landmark for the city of Munich, but has been a precedent for many more innovations in this field of study in later years. It is especially the size and the grandeur of the roof which has inspired many architects and designers. In here we can see the uh, section of a stadium, and the roofs also can be seen with the cable and the membranes used to cover the visitors' seating spaces. And this is the workers that use that try to install the membrane parts to the saddle roof. The cable nets are doubly curved. The resulting double-curved shape prevents the canopies from easily fluttering in the wind. The total length of steel cable in the complex exceeds 408 km, and tension loads in the cable net are as much as 5,000 tons. Originally, the foundation design was intended to consist of pre-stressed anchors. Local code officials, however, instead on more conservative piers to provide stability. In some cases, these piers are as much as 18 meter deep and 6 meter wide. These enormous foundations were required to resist the tremendous tensile stresses in the cable network and the live loads imposed by winds across and under the open structures. The blue part is the roofs, tensile roofs that covers space. And this is the pipe structures. There are lots of piping to uh, provide hot and cold water. And these are the some photographs and diagrams and sketches of the Munich Stadium. The complexity of the project can be seen. There are lots of tension members with steel ropes, and the connectors and the pins of the stadium. And this is the one unit of the stadium roof. And there are several units like that to cover the seating spaces. And this is the thickness of the steel bars which hold the, how can I say, whole mess. And it is from the interior, from the visitor's eyes, how the roof is seen. Thank you so much for listening to my presentation.